Hi everybody, today we're going to be talking about lesson 7.4, Approximating Square Roots. Take a look at your key idea here. It says a rational number is a number that can be written as the ratio of two integers. An irrational number cannot be written as the ratio of two integers. The square root of any whole number that is not a perfect square is irrational. The cube root of any integer that is not a perfect cube is irrational. The decimal form of an irrational number neither terminates nor repeats. So I know this is a lot of text, but let's go ahead and see what they're talking about. This graphic here is actually really helpful. Real numbers, rational numbers, and irrational numbers together form the set of real numbers. So when we're talking about real numbers, and you won't be learning about numbers that are imaginary until later on, not this year. Probably starting next year. So we have two kinds of real numbers. We have the set that's called irrational, and then we have the set that's called rational. So when you're given a number, you want to first figure out, is it rational or is it irrational? Now, irrational, there are fewer numbers that are irrational that we work with than rational. So some examples here are pi. Because pi goes on forever. So here it's 3.14, etc., 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 goes on forever. And remember here, it says that the decimal form of an irrational number neither terminates nor repeats. Okay, so this one never ends. It never terminates, right? So anything with a pi is considered irrational. These here are part of the numbers that says the square root of any whole number that is not a perfect square is irrational. And then the cube root of any integer that is not a perfect cube is irrational. So these here, for example, if you were to do the square root of 2, what's the answer? Well, it's not a perfect whole number, right? It's a number that actually, if you put in the calculator, goes on forever. So let's test it out. So if I were to do the square root of 2, you get this long number that actually goes on forever. It never terminates, and it's irrational. If you look at the cubed root of 7, it's also not a perfect cube, right? Like what number multiplied by itself 3 times gives you 7? It's an imperfect number, right? It's a number with a decimal that goes on forever. So you know your number is irrational if it has pi in it, if it's not a perfect square, or if it's not a perfect cubed root, or if it's just a number that goes on forever in decimal form. Rational numbers, however, when you think of the word rational, you probably think of the word ratio. So ratios are numbers that can be turned into fractions, right? Examples are 1/2, -2/3, 2.25, 0.3 repeating, right? What's 0.3 repeating? As a fraction, it's 1/3. So remember, going back to our definition, here, a rational number is a number that can be written as the ratio of two integers. So we have our fractions here, right? Once you figure out that it's rational, you can still classify it even more. It could be rational and an integer. For example, -1, -2, -3. Those are integers. Integers, remember, are numbers on the number line, positive and negative. You might want to take note of that so that you remember. So -1 is an integer. It lies on that typical number line that we see. And also it can be turned into a fraction. Remember that anything that can be turned into a fraction is considered rational. Then you can keep classifying it even more. Whole numbers are numbers 0, 1, 2, 3, and on. Only positive, right? But starting with 0. For example, the number 0 is whole. It's an integer, and it's rational. And then you can keep classifying even further as a natural number. Those are just the regular counting numbers that we learned in preschool. 1, 2, 3, 4, so on and so forth. So that's how you would classify numbers. Let's take a look at some examples. All right, so example 1 says to classify each real number. So we have the square root of 12. Well, going back to our definition, can you find the square root of 12? If you were to do it, say you wanted to do on the calculator, the square root of 12 is a number with decimals that go on forever. So it's not a perfect square, right? 12 is not a perfect square. So you would just assume then that it is irrational. So that one's simple. You just write irrational. Once you figure out that a number is irrational, that's it. You stop there. That's the only thing you want to classify it as. Okay, here we have 0.25 repeating. Again, remembering our definitions, it's really important that you refer back to this chart, and you probably will start to remember as you do more practice. It's a number that goes on forever. It has that line that indicates that those numbers repeat, right? So this is 0.25, 25, 25, 25, repeating. It goes on forever. So we know that it is rational because it fits that definition. Once it's rational, you want to look back and see, is it an integer? Remember, integers are numbers on the number line, both positive, negative, and 0. Is this an integer? Nope, it's not. So you would stop there. It is simply a rational number. It is not an integer. Here, if you were to simplify the square root, the negative square root of 9, that's simply negative 3. So going back to our chart again, we know that it counts as rational because negative 3 can be turned into a fraction. It's an integer because it lies on that number line. It is not, however, whole because whole numbers are 0 and positive numbers. So we can classify it as rational and integer, and you would stop there. So this is rational and integer. Okay, now take a look at letter D. Well, already you can tell that it's a fraction, so you would write rational. Is it an integer, though? Because that's the next level down. Remember, integers are numbers that go on the number line. So simplify the number, 72 divided by 4. Well, let's see what we get. 18. Perfect. So yes, we can assume that it is an integer because 18 lies on that number line, right? Is it whole? Yeah, because it's a positive number. And is it natural? Yes, it counts as those counting numbers that you typically would see. So we have rational, integer, whole, and natural. Okay, and then pi, well, we already know from the example earlier that it's irrational. And once you figure out that it's irrational, you can stop there and you don't have to classify it any further. All right, example 2 is asking us to approximate a square root. Estimate the square root of 71 to the nearest a integer and b tenth. We're not going to worry so much about estimating to the nearest tenth. So I'm going to show you how to estimate to the nearest integer. Well, if you think of 71, first you can just list out your perfect squares, right? I think right away that 8 times 8 is 64. So I know the square root of 64 equals 8, right? That's smaller than 71, so I'm going to think about 9. The square root of 81 is 9. So, all right, so now that we have the two roots, we know that the square root of 71 is in between the square root of 64 and the square root of 81. So it is closer to the square root of 64. So when it says estimate the square root of 71 to the nearest integer, really you're going to choose 8. Okay? If you wanted to check on the calculator, what that would be, the square root of 71 is 8.42. So it's definitely closer to 8 than it is to 9. All right, this one's asking for you to compare real numbers. So it's saying which is greater, the square root of 5 or 2 2/3. So if you do the square root of 5, and of course you can approximate if you kind of wanted to get an estimate. So 2.23 sounds about right. So this is 2.23, and you're comparing that with 2 2/3. If you were to do 2/3 on the calculator to see what that is as a decimal, you just do 2 divided by 3 to get 0.6 repeating. So this one here is 2.6 repeating. You're comparing that with 2 2/3. Which one's bigger? The 2.6 repeating, right? So really you would make sure that you write down the original answer, 2 2/3. Number 4, approximating the value of an expression. The radius of a circle with area A is approximately the square root of A divided by 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. So here we have 51 square inches for A. So you're simply going to plug in 51 where the A is. So the square root of 51 over 3. It says estimate its radius to the nearest integer. So if you simplify 51 over 3 on the calculator, you're going to get 17. So here we're really talking about the square root of 17. Okay, and if you were to approximate, I already know that the square root of 16 is 4. That's very close to the square root of 17. If I go up 1, the square root of 25 is 5. So I would go with 4 because that's the nearest integer. So you'd say it's approximately 4 inches.